Hi there, 6th grade math students. This is chapter 12.2, surface area of solids. We're going to learn to find the surface area of a prism and of a pyramid. Let's get started. This wooden box is painted green all over its exterior. The total area painted green is what we would call the surface area of the box. It is the area of all of the plane surfaces and base surfaces on the exterior of the prism. This wooden cube has edges that measure 5 centimeters each. So we're going to find the surface area of the cube by drawing the net of the cube. Here's the net. We can now find the area of the cube by finding the area of each one of these squares within the net. Another way to think about this is that the surface area of a cube is simply the area of its net. Makes sense, right? Because you're going to fold the net up to make the exterior surface of the cube. All right, so let's solve. If the area of one square face is 5 times 5, that means the area of each one of our faces is 25 centimeters. How many faces do we have? We have 1, 2, 3, 4, 5, 6. So we're going to take 6 times 25 to find a surface area of 150 centimeters squared. That's it. That's how we find the surface area of our cube. If you want to use a formula for this, and it's a cube, and you know that all 6 sides have the same measurements, you can simply take 6, the number of sides, times e for edge squared. Okay? Let me show you how we would do that here. That would be 6 times e, which is 5, squared. So 6 times 25, 150. See how that works? All right, let's go on to the next problem. Now let's find the surface area of a rectangular prism. The rectangular prism here is 12 inches long by 8 inches wide by 4 inches high. So let's find the surface area of the rectangular prism. The first thing I would like to do to find that surface area is to unfold the rectangular prism into its net, like this. The box here tells us that the opposite faces of a rectangular prism are congruent rectangles. Remember, that means they're exactly the same size and shape and could be superimposed over one another. So in the net, each pair of the congruent faces is the same color. So can you visualize how the net forms into the cube where our bases are green? The faces that are 4 inches by 12 inches are purple, and the faces that are 8 inches by 4 inches are red or pink, whatever you want to call that color. All right, so from here we know that the surface area of a rectangular prism is the area of its net. So now what we need to do is find the area of each one of these rectangles. Okay, let's begin with the green faces. The green faces have an area of 12 times 8. I'm going to go ahead and multiply that by 2 because I know that I have 2 green faces. Well, I don't personally have 2 green faces, but the rectangular prism has 2 green faces. So we're simply going to take 12 times 8 times 2 to get 192 inches squared. Next up, let's find the area of the purple rectangles and the kind of orangish, reddish, pinkish rectangles. There's a nice little math trick that we can use here to make this job really simple and really easy. Okay, the surface area of a prism is going to be equal to the perimeter of the base multiplied by the height, and then you add the sum of the areas of the 2 bases. Cool, huh? So we've already found the sum of the area of the 2 bases. Now let's find the perimeter of the base multiplied by the height. All right, so the perimeter of the base is going to be measured around here, correct? So we have 8 plus 12 plus 8 plus 12, which gives us a perimeter of 40. 40 inches is our perimeter. We're going to multiply that by our height, which is 4. So this tells us that the area of these 4 faces is 40 times 4, or 160 inches squared. We could figure this out too, one by one, just to make sure it works. Let's do that so that you trust me. Let's first find the area of these little pinkish reddish triangles. That'll be 8 times 4 times 2. That equals 8 times 8, or 64 inches squared. Now let's do the purple ones. 12 times 4 times 2. Well, let's see, that would be 12 times 2 is 24, times 4 is 96. Let's add these together, and look at that, we get 160. Okay, so now that you've seen it really does truly work, just go ahead and use that other formula, which is perimeter of the base times the height. Okay? Now to find the surface area of the entire rectangular prism, we just add this all up, and we get a total of 352 inches squared. All right, let's go on to some practice problems. Try these two problems on your own. In problem number 1, the yellow cube has edges that measure 6 centimeters each. Find the surface area of that cube. Remember, you can take the number of sides, 6, times the side length as e squared to find the surface area. Next, in number 2, let's find the surface area of this rectangular prism. It measures 7 inches by 5 inches by 10 inches. Remember, you'll start by finding the area of the base, which is length times height times 2. And then you're going to find the perimeter and multiply that by the height. Add the two together and you'll have your overall surface area. Just in case this is a little tricky to see, this line length is 10, this line length is 5 inches, this line length is 7 inches, as well as this one. Okay? This length here is also 5. All right, that should give you all the information you need to give these a try. Press pause while you work. We're going to look at triangular prisms when you get back. Now let's learn to calculate the surface area of a triangular prism. The triangular prism shown here has 3 rectangular faces. Its bases are congruent isosceles triangles. Remember, isosceles triangles have 2 sides that are the same length. Find the surface area of this triangular prism. All right, let's begin, as we always do, by opening up the triangular prism into its net. Now we can look at what shapes we're truly examining here. We have 2 different sizes of rectangles and 1 size of triangle, as indicated by the different colors on the net. So we'll begin by finding the total area of the 2 purple rectangles and adding that to the area of the orange rectangle. That's going to give us the area of our faces. So the area of our purple rectangles is going to be 5 centimeters times 11 centimeters times 2, right, because there are 2 of them. And that's going to give us an area of 110 centimeters squared. So that takes care of our 2 purple rectangles. Now we're going to go ahead and add in the 6 times 11 for this kind of orangey colored rectangle. And we don't need to multiply by 2, there's only 1. That gives us an area of 66 centimeters squared for a total area of 176 centimeters squared. Now there is a little math shortcut that we can use here. If we add up the width of the 3 rectangles and multiply that by the height, we're going to get the same answer. Let me show you how that works. If we take triangle 1, 5, plus triangle 2, 6, plus triangle 3, 5, and we multiply that answer by the height, 11, we're going to get 176 centimeters squared. 16 times 11 does indeed equal 176. So you can also use that technique if you find that to be easier. I first learned to do it by finding the full area of each one and then adding them together. So that still tends to be my default method. However, if you like this better, please use it. Now to finish up, we're going to find the area of the two yellow triangular bases. And we find that by taking 2, because there are 2 faces, times the area of each of the triangles, which will be 1/2 times 4 times 6, giving us an answer of 24 centimeters squared. So the total surface area of our triangular prism will be 176 centimeters squared plus 24 centimeters squared, giving us a final answer of 200 centimeters squared. All right, this one looks like fun. Let's find the surface area of our square pyramid. This pyramid has a square base measuring 10 inches on each side. It has 4 faces that are congruent isosceles triangles, and the height of each of those triangles is 12 inches. So let's find the surface area. Let's examine the net, remembering that the surface area of any solid figure is the area of its net. We begin by finding the area of the base, which is going to be 10 times 10 for 100 inches squared. Now we find the area of the 4 triangles, 4 times 1/2 times 10 times 12, which gives us a total area of 240 inches squared. The total surface area of the pyramid is simply the sum of these two numbers. So 340 inches squared. That was a piece of cake, wasn't it? Let's wrap up this section with these 2 final practice problems for you. In problem 3, there's a triangular prism with 3 rectangular faces. Its bases are congruent right triangles. Find the surface area of this triangular prism. Just in case it's tough to see, this length is 9 centimeters, this is 13, this is 5, and this is 12. Remember, you can use either technique, adding up the 3 widths and then multiplying by the length, or you can find the area of this, and this rectangle separately and add them all together, whichever one you prefer. Then going on to number 4, here we're making a pyramid that has an equilateral triangle at its base. The other 3 triangles are congruent isosceles triangles to create the faces. When we measure the length shown on the net of the pyramid, we get 5.2 inches for the height of the gold triangle. The height of the white triangles is 10 inches, and the base measurement for each is 6 inches. Find the surface area of this pyramid. Do your best to figure these out. If you get stuck, no worries, we'll work them together tomorrow. When I see you tomorrow, we'll do more work with finding surface area of solid figures. I'll see you then.